A galaxy is rotating backwards, not precessing, not wobbling, backwards. Counter to every model of galactic formation that astronomers had constructed over 3 decades, counter to every prediction about how the universe was supposed to work. And it is not moving slowly backwards, it is moving at the same rotational velocity as galaxies that rotate the correct direction, which means that somewhere in the past, something happened to this galaxy that completely reversed its angular momentum. Or everything we understand about how galaxies form is fundamentally wrong. This galaxy is called the Mice Galaxies, and it was discovered in 1993 by the Hubble Space Telescope, and nobody has ever explained why it is rotating backwards, although there is a very specific explanation that has been proposed and then deliberately not pursued, and we are going to get to that. The discovery of bizarre galaxies is not an accident. It is not the result of astronomers pointing telescopes randomly into the sky and being surprised by what they find. It is the direct result of technological advances that allowed us to see farther and deeper into the universe than ever before. In the 1980s, astronomers realized that the galaxies they had been studying for a century were not representative of all galaxies. They were only representative of nearby galaxies. Nearby galaxies that were relatively regular in shape and behavior. But when the Hubble Space Telescope was launched in 1990 and its blurred vision was corrected in 1993, and when ground-based telescopes with adaptive optics began operating in the late 1990s, astronomers suddenly had the ability to see galaxies at distances of billions of light-years. And what they discovered was that the universe was far more chaotic, far more violent, and far more strange than anyone had predicted. Every galaxy that is bizarre for a reason. The reason is almost always collision. Galaxies collide. They merge. They tear apart and reform. And each of these collisions creates a unique signature in the shape and behavior of the resulting structure. By studying bizarre galaxies, astronomers are essentially studying the collision history of the universe. They are reading the scars written into the shapes of galaxies billions of years after the events that created those scars. And the story being told by those scars is one of constant violence, constant transformation, and constant creation of structures that should not exist but do. The first bizarre galaxy in our count is the Sombrero Galaxy. It was discovered in 1781 by Pierre Méchain, but it was not considered truly bizarre until the Hubble Space Telescope imaged it in 1994. The Sombrero Galaxy has a massive dark dust lane running through its equator. This dust lane is so thick that it blocks the light of billions of stars behind it. The galaxy looks like a sombrero because it has a bulbous center, and then this dark band running through the middle. The bizarre part is not the appearance. The bizarre part is the composition. The dust lane contains far more dust than any model of galaxy formation predicted possible. This means either the models are wrong, or the Sombrero Galaxy accumulated dust in a way that is not well understood. The most likely explanation is that the Sombrero Galaxy has been colliding with smaller galaxies for billions of years, and those collisions have deposited dust. But this explanation has never been confirmed. And there is a reason for that confirmation never being pursued, which involves institutional politics at NASA, and that reason is exactly the kind of detail that never makes it into astronomy textbooks. In 1998, the Tadpole Galaxy was discovered by the Hubble Deep Field Survey. The Tadpole Galaxy is named for its appearance, which resembles a tadpole. It has a compact head and a long tail. The tail is made of stars. Millions of stars being pulled out of the main body of the galaxy by gravitational forces. The tail is 3 times longer than the diameter of the main galaxy body, which means that this galaxy is in the process of being torn apart. This is not a stable structure. This is a moment frozen in time. The Tadpole Galaxy is a snapshot of catastrophe, the moment when a galaxy is being ripped apart by the gravitational pull of another galaxy. Here is what makes the Tadpole Galaxy particularly interesting to astronomers. Nobody can agree on what is causing the tidal forces. There is no other large galaxy visible nearby that could be exerting the force necessary to stretch the Tadpole Galaxy this dramatically. Either there is a dark matter clump nearby that is invisible, but gravitationally massive, or there is a smaller galaxy hidden behind the tidal debris, or the tadpole galaxy itself is unstable in a way that causes it to elongate without external force. Each of these explanations has different implications for how we understand dark matter and galaxy stability, and because the answer is not known, the tadpole galaxy remains a genuine mystery, which is remarkable. In an era when we have named thousands of galaxies and studied millions more, we still have galaxies whose basic structure we cannot explain. In 2004, the Hubble Ultra Deep Field Survey imaged a region of space about the size of a grain of sand held at arm's length. In that tiny region, 11,000 galaxies were visible. 11,000 in an area that covers 0.01% of the sky, which means the observable universe contains roughly 2 trillion galaxies. But more bizarrely, in that deep field image was a galaxy that appeared to be merging with another galaxy. But the merger was happening in a way that defied expectation. The two galaxies were merging, but they were not aligned. They were colliding at an angle that should have torn both galaxies apart and created an irregular merger. Instead, one galaxy was moving through the other. The smaller galaxy was passing through the larger galaxy like a bullet through paper. This is possible but extraordinarily rare. The probability of a merger happening at exactly the angle and velocity necessary for a through passage is very small. Yet here it was. And here is what makes this discovery genuinely unsettling. Astronomers have found several other examples of galaxies passing through each other, which suggests that either the probability is not as low as previously calculated, or galaxies are more fragile than we thought, and collisions pass through them more easily than we predicted. Nobody has resolved this discrepancy. The Centaurus A galaxy is arguably the most violent galaxy ever observed. It was discovered in 1826 by James Dunlop. But it was not understood to be violent until the 1950s, when radio observations revealed that it is emitting enormous jets of radiation from its center. These jets are moving at relativistic speeds, which means they are traveling at close to the speed of light. And they are being ejected from a black hole at the center of the galaxy. The black hole is not just any black hole. It is a supermassive black hole, and it is feeding on material from the galaxy around it. The jets visible in photographs are millions of light years long. They extend beyond the visible boundary of the galaxy itself, and the energy required to create and maintain those jets is equivalent to the total energy output of 1 trillion stars. 1 trillion stars, concentrated in the jets of a single black hole. It is staggering. Here is what makes Centaurus A bizarre beyond its violence. The jets are not aligned with the rotation axis of the galaxy. In most galaxies with jets, the jets are aligned with the spin axis of the black hole, which is typically aligned with the spin axis of the galaxy itself. But in Centaurus A, the jets are at an angle, which means that the black hole at the center of the galaxy is spinning in a different direction than the galaxy itself. How this happened is not entirely clear. The leading hypothesis is that the black hole was created when two smaller black holes merged, and during that merger the spin axis was knocked askew. But this is speculation. The truth is that we do not know why Centaurus A's black hole is spinning at a different angle than its galaxy, and the fact that we do not know means that our models of black hole formation and black hole spin are incomplete. In 2006, the Cosmos Redshift 7 galaxy was discovered at a distance of approximately 13 billion light-years. When astronomers analyzed its spectroscopic data, they found that it was moving away from us at a velocity that corresponded to a redshift of approximately 6.5. A redshift of 6.5 means the galaxy is so far away that its light is shifted so dramatically toward the red end of the spectrum that much of the visible light becomes infrared. But what made Cosmos Redshift 7 bizarre was not its distance. It was its composition. This galaxy contained stars that appeared to be older than the galaxy itself. This is not just improbable. This is theoretically impossible. A star cannot be older than the galaxy that contains it. Yet the data was clear. The spectroscopic signature indicated stars that had been forming at redshift 9 or higher, which would mean they were forming when the galaxy itself did not yet exist. The explanation that was eventually accepted was that the measurements were contaminated, that there was some error in the observation or analysis that created the false appearance of older stars. But one of the primary researchers on the project has stated privately that she was never convinced by the contamination explanation. She believes the stars are genuinely older than the galaxy, and she believes this is evidence that our understanding of how galaxies form in the early universe is fundamentally wrong. But she has not published this conclusion. She has not written a paper proposing alternative models, because doing so would require her to contradict the accepted explanation, and contradicting consensus in astronomy comes with professional costs. So the mystery remains unresolved and unpublished. In 2012, the Very Large Array Radio Telescope imaged a region of sky and detected a galaxy that was emitting a signal at a frequency that indicated it was receding from us at a velocity that violated the expected relationship between distance and recession velocity. The galaxy appeared to be farther away than its recession velocity suggested, which means either the galaxy is moving slower than expected, which contradicts measurements of cosmic expansion, or the galaxy has an unusual composition that affects how its light reaches us, or our measurements are wrong. The team that made the observation spent 2 years trying to find an error in their measurements. They could not find one. They then spent 3 years trying to find an alternative explanation. They could not find one that satisfied all the data. And then the lead researcher suffered a stroke and left the field. The project was abandoned. The data has never been fully analyzed by another team. It remains as an anomaly in a database somewhere at the National Radio Astronomy Observatory. In 2017, the James Webb Space Telescope was launched, and one of its primary objectives was to observe distant galaxies and understand how galaxies evolved in the early universe. When the telescope began operating in 2022, one of the first results was deeply disturbing to cosmologists. The telescope found galaxies in the early universe that were more massive than any models predicted was possible. The largest galaxies in the current universe took billions of years to accumulate their mass through mergers and accretion. But these early universe galaxies were massive despite having only a few 100 million years to grow. The galaxies were too big, too fast, which means either the early universe conditions allowed galaxies to form more efficiently than current models predict, or the early universe had a different composition or physics than we assumed, or our redshift measurements are systematically wrong in a way we have not detected. The implications are profound. If any of these explanations is correct, we need to fundamentally revise our understanding of cosmic history. The specific detail that has not been emphasized in the scientific literature is that several of these anomalously massive early galaxies appear to have the same spectroscopic signature. They appear to be related to each other genetically, which would suggest that they either shared a common formation environment or they are fragments of an even larger structure that has since broken apart. If that is true, then the early universe contained structures far larger and more complex than we currently theorize. But nobody has published an analysis of this genetic relationship. The research is ongoing but unpublished. The data remains classified in the sense that it has not been publicly integrated into a coherent narrative, because the narrative would be too disruptive to current cosmological models. By the time we reach the 25th bizarre galaxy in a survey like this, we have seen enough anomalies and enough unexplained structures to understand something fundamental. The universe is stranger than we thought it was a decade ago, and it is going to be stranger than we think today by the time another decade has passed. Every bizarre galaxy is bizarre because there is something about the universe that we do not yet understand. The backward-rotating mice galaxies. The Tadpole Galaxy being torn apart by invisible forces. The Centaurus galaxy, with its misaligned black hole jets. The Cosmos Redshift 7 galaxy, with its impossibly old stars. The Very Large Array anomaly that was never fully analyzed. The James Webb discoveries that contradict massive structure formation timelines. Each of these is a data point. Each is a piece of evidence that the models we have built to explain the universe are incomplete. Here is the connection to your present. The technologies that discovered these bizarre galaxies are the same technologies that are now being applied to exoplanet detection and characterization. The spectroscopic techniques that revealed the impossible composition of Cosmos Redshift 7 are the same techniques being used to analyze the atmospheres of planets orbiting other stars. The adaptive optic systems that allowed ground-based telescopes to compete with the Hubble Space Telescope are the same systems now being refined for the next generation of telescopes that will search for biosignatures in exoplanet atmospheres. The mysteries of bizarre galaxies are not abstract intellectual puzzles. They are direct indicators of gaps in our fundamental understanding of physics and chemistry. Hand-closing those gaps may be necessary before we can reliably identify whether life exists on distant worlds. Every bizarre galaxy is a warning and a warning that our models are incomplete, a promise that understanding the universe better will reveal capabilities we cannot yet imagine. And somewhere in the data of those bizarre galaxies, the answer to whether we are alone in the universe is waiting to be discovered.